what's inside a central heating pump? Well, my name's Derek from Tomcat Gas Training, and if you stick around, that's exactly what you're going to find out. What is inside a central heating pump? There are two major players in the manufacturing of central heating pumps. They are Vilo. Now, Vilo have been around since 1872, and Grundfos. But Grundfos have only been around since after the Second World War. 1945 they came about. So what we're going to do is we're going to have a look at why we need central heating pumps, and then we're going to get to the nitty gritty and see what's exactly inside a central heating pump. So let's stop messing around and let's get on with it. Now, these pumps are basically the same inside, but what we're going to do is we're going to look at the most common pump out there, which is the grundfos one. Now, the grundfos pump is made up of a few parts. First of all, what we've got is, this is the body and this is the head of the pump. So the head is joined to the body by 4 screws, so Allen screws. So we need a 4mm Allen key to undo these. So I'm just going to take these 4mm screws off. That was tight. So first of all, you can even see the pump head is designed so you can actually get in to undo the Allen screws. So that's the first thing. Now, I don't think this has ever been off, this one. So now we've pulled this apart. I can see the reason why this is in the centre, because the first thing I notice is the shaft. So the impeller has snapped off the ceramic shaft. Okay. So that's the first thing what's wrong with this. So you can see it's a bit rusty inside. Now then, so let's look at the body first. So first thing you can see is there is an in and an out. And we can tell this by, there's a flow arrow here. But another way you can tell which is the in and which is the out is this bulge here is where the water comes into the bottom of the impeller, and where there isn't a bulge, it's where it goes out. So you can see there is an arrow on there, but if you can't read that arrow, then the bulge will tell you exactly which is the in and out and which way the pump is pumping. It will only pump one way. Now, the impeller. The impeller is the important part of the pump. It needs to move free, and obviously this didn't move free. It snapped off as I pulled it off, or it could have been snapped off anyway. It's one of the trainees or ex-trainees has brought this in for me. So this probably wasn't working, that's why it's come out. Now the impeller, what happens is the water, which you can't see in here very well, but the water comes through here. So where the water comes up that hole there, and the impeller sits on the top there. So the water has to go through the middle of there, and then the water's flung out of there, and then it goes down through a slot through there. Okay, so that's how the water gets into the pump and out of the pump, and all central heating pumps are pretty much working on the same. Now, the impeller, a lot of pumps come with 3 speeds, but the 3 speeds is really the pressure. Now, if you've got a small system, you should have it on a low speed or low pressure, and if you've got a big system, then you should have it on a fast speed or a large pressure. Now, if you've got a really noisy heating system, that could mean that the water's going through the radiators that quick. One, it's not efficient, and 2, it's making this horrible noise. So you can actually adjust them. On the new ones now, on the ERP pumps, they automatically adjust the flow rate to reduce the pressure, so we don't really... Well, we'll look at those later. Now, what the impeller can also do is what's called cavitate. Now, cavitate is basically, if the impeller's spinning, it will create air bubbles, and it basically makes the water around the impeller boil and creates these air bubbles. And if you've got a noisy pump, then you've got it you can hear the air bubbles popping. So that's not good for a central heating system that we're making air. Because if we're making air through cavitation, then we're creating corrosion. Now, this cavitation as well creates heat. So if you go to a central heating pump and that's the motor and this head is completely red hot, then there's every chance it's full of air because there's no water in there, and it's that air what's boiling as the pump's spinning. And you can actually release that air by undoing the screw on the end of there. That will release, so that's your bleed screw. On the new ERP pumps, there's no bleed screw. But again, we'll talk about those as we're going along. So that's one of the major things what goes wrong with pumps is they get full of air and they cavitate and they create this heat and it causes problems. So if you can hear your pump running, there's every chance there's air in there because you shouldn't hear it running. It could be running too fast for the heating system. So that's one of the major problems with pumps. So we've started to see what's inside these pumps, so let's have a closer look at them. Now we've had a look at the body. The only other thing to look on the body is this is the rubber seal, and what Grundfos say is they'll guarantee that'll reseal if you take the head off. So you shouldn't have to remove that seal if it's in a good condition. So that's the seal in the body. Now the way the head is made up, we have basically, this is the magnet rotor here, and this is the stator in the head. So this is the windings, so the copper bit there you can see is the windings. So you can see the little stator parts inside there, and what that does is it puts the power to those making a circle, which allows this now to rotate around the head. Now, it needs to be kept separate from the head, because there's water in there, and this is what this little bell housing does. So the actual rotor sits inside the bell housing, and the bearings inside here are lubricated by the central heating water. The pump, believe it or not, even though the water is 82 degrees, or could be 82 degrees, the pump is cooled by the central heating water. Okay? So you can see the impeller attached in the shaft, you can see the bell housing, and the bell housing then would sit in there, and that makes this completely watertight from this, so water can't get into the motor. Now the bleed screw is in the end of the bell housing. So you can see the bleed screw there, and that's how we get rid of the air to fill this bell housing with water, so it allows the magnet rotor to keep lubricated. And this is where the boiling of the water occurs, which then turns to steam, which is when you release this, sometimes you get the steam coming out. Okay, so you've got to be careful because it's 100 degrees. That's pretty much how it's laid out inside here. And the little cutaway there, you can see it quite clearly now how this is put together. Now let's have a look at the electrical side. Now the first thing we see on the electrical side is this thing hanging out. So let's find out what this is and what it actually does inside this pump. So you can see from the writing on this, it says it's a capacitor. So what's a capacitor? Well, basically it's like a battery because they store energy. But the difference between this capacitor and a battery is the capacitor can store and replace the energy a lot quicker than a battery can. But the battery does have one over on the capacitor, that it can store a lot more energy for a lot smaller size. So that's basically what a capacitor is. It's some way of storing energy. Now this is a start capacitor. So there are also run capacitors in a motor. So this pump just needs a start capacitor to give it that energy to actually make it move when it's trying to move the water. Because if we didn't have this in line and it tried to move the water, it would probably blow the fuse because it would draw too much power from the mains and then blow the fuse because we'd only have like a 3 amp fuse in there. So these have quite high voltage but low ampage again. Now basically what they are two plates inside here, so not going into too much detail, but there are two plates in here, and one side stores the energy and the other one releases the energy, and it can draw the energy back from the mains. They are cooled by an oil inside there, so if you did get this brown oil leaking out of them, then they need to be discarded because they're broken. So like I say, this is a start capacitor, and this is what's going to give the pump the energy to able to move the water on startup, and that's all it does. So it dissipates its energy through these two wires here on startup, and then recharges itself while the pump is running. So you could have a fault on the pump where the pump won't start, but if you spin it so if you take the bleed screw out and spin the shaft and the pump starts running, then there's every chance this start capacitor has gone, because this is only here just to start the actual pump. So let's have a look at this writing on here. So you can see it says 2.6, and then we've got like this little U with a tail and an F. That means microfarads. The actual charge in this capacitor is 2.6 microfarad, and you can see it says plus 10% or minus 0%. That's because it's on an AC voltage. It can hold a little bit more than that, not less than that, but it can hold 10% more than that. So you can see it says 400 volts AC, 50 to 60 hertz. So in the UK we're 50 hertz, in America they're 60 hertz. Okay, so that's where this 50-60 comes from, and that's your 50 cycles per second, I think. Not being an electrician, but I think that's what that means. Now the 400 volts AC is what it can take. So if you put this, if this only said 100 volts AC and you put it in the pump, because the pump is 230 volts, this would explode. Okay, so that's what that means. That's the voltage it can take, 400 volts. And then the big 2.6 is just the microfarad. So that's what it means on this start capacitor, and that's the start capacitor on this grundfos pump. Now we've looked at the old start capacitor. The only other things we've got in here are, this is the speed or the pressure selector switch. And then we've got our earth connection, our neutral connection, and our live connection for our cables. Our cables come through the cable gland here. So this is the cable gland. You can see it's cut out at the bottom, so it slides in there. Now getting the cables in here is dead easy. You don't even need a screwdriver, so you can just pull them back, which opens a little gate in there, which allows the cable then to go in. So a little bit fiddly for big fat fingers like mine, but you can just see on the live there, you can see the actual cable gate opening. And that's pretty much what you've got inside. Now, last couple of things with the head. What we've got here, we've got some numbers here. So 1550 means 15 is the diameter inside here, and the 50 means 5 meters head. So if it was a 1560, it would mean it was a 6 meter head. And the 130 there means from face to face of the flanges, face to face of these flanges, it would be 130 mil. Now the other thing is, depending on which way the pump is installed, you can actually have 4 different directions of where you can spin the head and it will still work. Because one thing you don't want to do is you don't want the electrical connection to be down at the bottom, because obviously when you're bleeding it here, the water would run down into the power. And you also want the electrical connection at the top, so you could always get at the electrical connections when it's in situ. So always follow the manufacturer's instructions on the right rotations for installing a pump. But with these grundfos pumps, you could spin them in 4 ways. Now the other thing as well in the old pumps is the bodies were the same, and you could interchange the heads no matter how old the body was. So if you had a body in position which was in good nick, this definitely isn't, and you just wanted to change the head, then you could just change the head. It was quite handy that for when it was inside a combination boiler. So that's a look at the pump head. Now, before we move on to have a look at the new UPS 3 pump, let's just finish off with the old UPS 1-2 pumps, the common faults you're going to find. Now, the first thing we talked about was the capacitor and how you can check whether the capacitor's gone or not by simply, if you go to a pump and it's not working, just flip the pump while you've got power and through the screw here, and if it starts up, then what you've got to do is you've got to turn off the pump, then let it stop on its own and then try it again. If it starts up again, then it was just the pump stuck, but if it doesn't start up again, then the capacitor's gone. And freeing the pump is through this little screw hole here. You get a screwdriver, turn it left and right, and it'll free it off. Because in the summer months when you're not using your central heating, this is not in a combi, this is on a traditional system. In the summer months, if you're not using your boiler for heating, what can happen is the pump can stick. So that's one thing. Now, another thing is if you go to your pump and you hear it rattling, really rattling, and you turn the selector switch up and you can hear it really making a clunking noise, a lot of the time what that is the impellers fell off. So that's the impeller rattling around on the inside. So that's another common fault we've got. If you hear this noise, this is the bearings are dry, so that means the pumps have probably been installed wrong and the pump is full of air, so the bearings have dried out. Another fault is it's not running and it's got red hot, which we talked about. That could be it's got full of air, it's cavitated, it's not pumping any water. Again, you can open the bleed screw if you get air, steam, water coming out of there. Then you can screw the screw back in and it should run. So they're the common faults. If it's not doing anything, if it's freezing cold, it's not doing anything, then it's every chance that the pump might have burnt out or one of the controls isn't working, and that's a little bit more in depth. If you look at our video on the history of central heating, I go into pumps that way in a little bit more depth. So that's a look at the UPS old pumps. So what we're going to do now is we're going to look at the UPS 3 pumps. These superseded this pump, I think it was 2018, 19, was it 2019? 2018, I think these came out. And what I'm going to do now is I'm just going to show you this replacement app thing what Grundfos have brought out, which is really good. So we're going to have a look at that, and then what we'll do is we'll take a close look at this and then finish off with pumps in boilers. Now, before we go on to the new pumps, I just want to show you this app from Grundfos. This is a Grundfos Go Replace app. Okay, it's available for all phones, I think. But what we need is this PN number. So if you come to a combi boiler or a system boiler and it's got one of these pumps in, and we want to know if we can replace it with one of the new pumps, all we need to do is, first of all, activate the camera and take a picture of the PN number. It's now going to find the product for us. So it says that's the product number. We're going to go next. Saying, is that the number? Yes, it is. Next. And look at that. It's just told me what pump I can use to replace if that was in the boiler. And it says we recommend that you only replace the pump head. So that new pump will still fit on the old body of the old pumps, and they reckon you can go back 15 years on boilers with this. So I think every engineer should be having this app, and this puts in the new UPS 3 pump. So let's go and have a look at this UPS 3 pump then. Now the first big difference we see is they've changed the colour. Don't know why they've done that, but anyway, they've changed the colour. Second big change is how you wire it up. There's a plug now. It's over here, hang on. We've now got this external plug, what clips on. So you're wiring that up, you're not actually going into the pump head now. Now it's still got the same 4 screws, and we've still got the cutouts on the pump head, so we can still undo the pump. This is a lot lighter than the old heads. That's the first thing you can see. And look at the size of the impeller. It's tiny. tiny little impeller now. That's probably so it can fit in most boilers, most combi boilers, that. So the body looks exactly the same. It's still laid out the same. So this head, let me go back and get the old body. Back. So this should fit on there perfectly if it weren't all crusty inside. Yeah, that fits on. It's just all really crusty inside there, so you can hear it crunching. Other big thing we see is there's no bleed screw in there. Now what we've got to do is, if this seizes, this has a few fancy functions in it, better than that one. First of all is it has fault codes. What it also can do is it can try and free itself by turning itself backwards and forwards. So if you go to a boiler and you can hear it buzzing, then there's every chance it's trying to free itself. But it gives you some coloured lights on here which give you the different faults. Now if it does get stuck, what we've got to do is we have to put a screwdriver in the hole and we have to push it first before we can turn it. So can you see me pushing it? But it needs to be a Phillips screwdriver. So let me just change that for a Phillips screwdriver. So we get a small screwdriver, we can put it in the end, push it, oops, and we can turn it. Okay, we don't push it too much. You won't be pushing it out anyway, would you? So you can see now pushing it and twisting it. Just twisting it doesn't do anything. You have to push it to free it to allow it to spin. Okay, so that's the new UPS 3. Now these are 50-65, so it can go up to 6.5 meters. Okay, why they just don't call it a 65 rather than 50/65? I don't know. Okay, so we've gone leaps and bounds now with the new pumps. This also has a setting for central heating and it also has a setting for underfloor heating. So this does loads of different applications. So this is your replacement pump. Now Vilo, they've got also brand new sets of pumps with fancy settings on them and anti-seize and all this rest of the settings. So pumps have come loads of leaps since 2013, since we've had to start looking at the energy rating of pumps, because if your pump's too fast you're going to be using a lot of energy if it doesn't need to, so your electric bill's going to go up. Combi boilers, the speed of the pump costing people a lot of money, so they've got to reduce them and they work on the return temperature. But anyway, we'll go and have a look in boilers now and I'll explain more about the ERP pumps inside the boilers. Now this is the common sight now in a combi boiler that we've got this ERP pump. Now what we can see on the pump is we actually have two connections going to it now. So we've got two lots of wires. So we've got a low voltage side and we've got a 230 volt side. So we've got the 230 volt side to get it spinning, and then we've got the low voltage side now to modulate it. So modulation, basically what it's doing is it's slowing the pump down to try and keep the return temperature lower than 55 degrees. Because if the return temperature comes back to a boiler greater than 55 degrees, it ain't going to condensate. Now also, it needs to reduce that energy as well it's using. So as it slows down, it's using less energy. But we can't reduce the speed without using the low voltage side on the boilers. Now, are they working? Can we tell they're working? This doesn't even have a screw hole in the centre here. You have to go through the sticker. So it's actually inside the sticker there. You could still put the screwdriver in and you can still do it. Now if I turn this boiler on, so what will happen now is a green light will come on the pump here and tell us the pump is actually running. But if it hasn't got that green light, we can actually use our non-contact voltage indicator to tell us that there is power actually going to the pump. Now we shouldn't be using these as a way of checking if anything's dead, but we can check and see that there is voltage going to this pump. So we know we've got 230 volts going to that pump, but it's also got a green light there to show us that it's working. And that's a look at what's inside central heating pumps. So if you've liked this video, why don't you give me that thumbs up, or leave a constructive comment down below. If you've not subscribed to our channel yet, then please subscribe. And don't forget to hit that notification bell, because even I don't know when I'm releasing videos. I'm releasing that many. Anyway, all I've got left to say is thanks for listening, thanks for watching, and stay in, stay safe, guys. Cheers.